Hey, welcome to Ones and Zeros. My name's Ben, and today we are taking a look at another in our series of STM32 basics videos. In this one today, we're actually going to be doing a fairly short one, looking at one of the more simple peripherals, which is the random number generator. Now, it's possibly one of the simplest peripherals you'll come across in the STM32 devices. Not all of the devices actually come with the random number generator built in, which is why today for this particular video we're not actually going to be using our typical F411 Nucleo 64 board, but instead we are going to be looking at our F769i Discovery board. And let's see if we can get a bit better focus on that one. That looks a bit better. So we're going to be using this one today simply because it does have the random number generator built into it. And we're going to have a bit of a look at how simple it is to set up, because it's a really easy peripheral to set up and actually get working. We'll get a bit of a driver written for it and then sort of see how it actually works and what we can actually do with it. So part of the reason why we're going to take a bit of a look at this one is because it can be really useful if you're doing things like writing games or doing things like that, where you need to be able to pull random numbers in order to make certain things happen depending on a particular value. So for example, my niece Finn has been doing really well with learning C++. I've been teaching her some embedded programming stuff to the point where she even got given one of these F769 boards because she was doing so well, and is actually looking at writing a little bit of a game on it. So as a result, we're looking at using the random number generator to help make certain things happen within the game world there. So that aside, let's have a bit of a look at sort of what it takes to actually get it set up and running, rather than going through and sort of seeing how we would approach it sort of like we've done in a couple of our previous videos. We're just going to go straight ahead and actually get a driver written for it, because it is such a simple peripheral. We can kind of explain all of the setup bits and all of that sort of stuff fairly easily as we go. So much like with most of our videos, the code from this one will be going up on GitHub not long after this stream as well. So first things first, we want to get a couple of files sorted out to chuck our driver into. So just call these QAD RNG.cpp. There we go. And let's just grab that one, and we will copy and paste our header from that one across to that. Stream looks like it's behaving itself properly, which is always good. So we'll just get our header renamed. So basically the random number generator is basically just used to generate 32-bit random numbers, basically on demand. Get that one in there. We're not going to need to include that one. Do our prevent recursive inclusion. Like so. That all looks correct, so we'll grab a copy of that and chuck it across to our source file as well. Rename that one to CPP. Get rid of these guys, and we're going to need to include QAD RNG.hpp in our source file. Excellent. So because there is only one random number generator in the devices that do include it, we are going to set this up as a singleton class, similar to the sort of approach that we've used previously with a bunch of our drivers. So let's get that class written. So we're just going to call it Q8E RNG. You'll have to excuse me, the coffee hasn't quite sunk in just yet at the moment. So now we're going to need a couple of things to be stored inside this class, one of which is actually going to be the handle to the peripheral that we'll use for accessing the HAL methods for that. So use our typical naming convention by calling it m_s handle. We're also going to need to make our constructor private because of the fact that it will be a singleton class. So we don't want to be accessing that constructor outside of the class itself. So that will just be Q8E RNG. Let's create it like that for the moment. And we'll also want to delete our copy constructor and assignment operator as well. Let me just make sure that I'm actually going to do this correctly. Brain's definitely not functioning properly at the moment. Let's just pop that over there. And awesome. Didn't think I was on the right track there, but we are now. So Q8E RNG other, and we'll delete that guy. Q8E RNG operator, assignment operator, and we'll delete that guy as well. So that's got those guys out of the road. Now, much like we've got over here for this singleton class for our memory controller, we are going to create our get methods, just so that we can retrieve an instance to the actual class itself. And I will have some unearthing C++ videos coming out soon where we start to look at classes and singletons and things like that in a little bit more depth as well moving forward. So if they don't make complete sense now, I'd recommend checking those guys out once they come out. So we're going to need some initialization methods. And this one will return a QA result. It'll be the method that we use to initialize it. And that is going to call our implementation initialization method there, like so. We're also going to want a deinitialization method. This one won't be returning anything, but it will be also calling our implementation deinitialization method. And we're also going to want some data methods. So for this one, it's fairly simple. All we're going to need is a method to be able to retrieve a random number. So this will also be static methods. Due to being a singleton class, it's going to return a uint32t. And let's just call this guy get value. We don't need to pass anything to it. And that can just return get imp get value, like so. So that's all our static methods done for our singleton class. Now let's get the actual implementation methods sorted out down here. So we're going to have some initialization methods and we're going to have some data methods, so we'll get those comments in there as well. Now the other thing that we might keep track of in here as well is whether or not the driver is actually initialized, which we'll just call me init state, and in our constructor we're just going to set me init state to QA not initialized, because it's not currently set up. And while we're in here, we'll also set our peripheral handle and just fill that one all with zeros, so that that's nice and clean and good to go as well. So back down to our implementation methods. Let's get these guys sorted out. So first one is going to be our imp init method, which returns a QA result. So we want that one there. So we're going to have our imp dinit method, and we're going to have our data method, which will be returning a uint32t, but doesn't need anything passed to it. Now we might also just pop in, so that we can check the state of whether or not we're actually initialized. Let's go with QA init state get init state, make that a void method, and then we'll just go return get me init state, just so that if we need to check whether or not that class is initialized from outside of the class, we can more easily do that. It might help if I jump to the correct screen. All right, sorry about that. Got a bit carried away there. All right, so we've got basically the class that we've laid out. So we're tracking whether or not it's initialized. We've got our handle to our random number generator handle type def. We've got our constructor, which has been made private because of the fact that we're using a singleton class. We've deleted our copy constructor and our assignment operator, and we've set up a bunch of our static methods for our singleton class. So our get method, which allows us to retrieve an instance of that singleton class. The constructor in the singleton class will be called the very first time that the get method is used. So say when we go to initialize it and it calls the get method here, it will actually call the constructor for the class at that point, for example. So we've got our initialization and deinitialization methods. We've got our method to be able to retrieve whether or not the class is actually initialized. We've also got our method to be able to return a random number. And then, of course, the implementation methods, which are accessed via our static methods. So this will look a little bit familiar if you've had a look through some of our previous videos in the Discovering STM32 and STM32 Basics series videos. So let's get these few methods all sorted out over here in our source file. So QA RNG initialization methods. Again, making sure we keep everything consistent with how we've been laying everything out for all of our other files, just to make it all nice and tidy. Grab that guy, pop him there. This will be a data method, and it's called getValue. There'll be D in it. We also need to make sure that we let the compiler know what class these methods belong to, like so. And there we are there. All right, so if we're already initialized, we don't need to reinitialize. So if me_init state is true, it means we're already initialized, in which case we can just return QA OK because we are already initialized. However, if we're not initialized, there's a couple of things that we're going to need to do. So the first of those is we're going to need to enable the clock for our random number generator. So, and we're going to do a force and release reset on that one as well. So enable RNG clock. Then we're going to need to take our handle that we've created, tell it what instance we want to be using. In this case, it's just going to be RNG. And then it's a matter of us going if HAL RNG init, pass it a pointer to that handle. So if that doesn't equal HAL OK, then we want to return QA failed. However, if it has succeeded, then we are going to return QA OK. So as we can see, to get that guy set up, it's actually really, really easy. It's probably the easiest peripheral to get set up. Enable the clock and tell it what instance we're using and initialize it. Really nice, simple one to get set up there. Now, as far as our deinitialization, in fact, what we might do here is if this initialization fails, we may also just go through and tell it to disable the random number generator clock. That way everything fails gracefully, so that if the initialization fails, we're back in the same state that we were in when prior to actually starting to do the initialization. And then as far as our deinitialization, we're going to first check that we are actually initialized. So if me_init state equals false, then we're just going to return. However, we also need to make sure that we set the driver state here as well, to make sure that we know that at that point we are actually initialized. So to deinitialize the RNG. It's just going to be a matter of calling HAL RNG deinit, passing it a pointer to the handle, like so. We'll then set the driver state to let us know that we are no longer initialized, like so. So again, really nice and simple for this one. Now, as far as actually getting the random number out of the random number generator, what we will do is we'll create a uint32 variable here, and let's just call him uval. Don't really need to pop a value in him, but we'll do that just in case anyway. So the particular method we want here is HAL RNG generate random number. Pass it a copy of the handle, or a pointer to the handle, as well as a pointer to the value that we're going to be storing our random number into. And then it's just a matter of returning uval back, which will then contain the actual random number that's been generated. So essentially, if we get a value out that's 0, there is a chance that it could just be a random number that does actually equal 0. However, it could also be indicative that there has been some sort of failure with generating the random number as well. Now, what we might also do is just check if things are initialized in here. So if we're not initialized, then we might just return 0 there as well, rather than it going through and calling HAL RNG generate random number, which might give us undefined results. So just to be safe, we'll pop that guy in there. And that is basically that driver. So probably the simplest one we've done so far. So again, perfect example of using a singleton class to give us access to a peripheral that only has a single copy of it inside the device. So let's go through and see if we can get it to generate some random numbers for us. So let's call this RNG update threshold. We'll set it to 1000 milliseconds, and every 1000 milliseconds we're going to get it to spit out a random number for us. And we'll do that via serial. So we'll pop in uint v2tu RNG update ticks equals 0. So RNG update ticks plus equals u ticks. Really can't type at the moment. So if RNG update ticks is greater than equal to QAFT RNG update tick threshold, then we'll also do RNG update ticks minus equals QAFT RNG update tick threshold. Now we'll also create just a temporary string just to hold the data that we're going to be sending out via serial. And it might help if we actually initialize this peripheral. So we're going to do this after all of our LCD stuff. So init RNG driver. Also going to need to make sure that we include the file for that one. So qad rng.hpp. Go back down to where we will be initializing that. So that'll be qad rng init. And we'll check to make sure that that has actually succeeded as well. So if it's failed, we will send out a message via serial. We'll turn on our red user LED to let us know that there's an error, and we'll chuck it into an infinite loop. However, if it's been successful, then we'll pop a message out just saying that the random number generator is initialized. So that's got all of that set up there, ready to go. Now, one thing I just need to double check here as far as using sprintf to format our value for us. Okay. All right, so that should work fine for us. So it should just be LU. I just needed to make sure of what I needed to tell it, because if we just went with %U, it's going to expect a 16-bit value. However, because we're dealing with a 32-bit value that's coming from the random number generator, we chuck the L in there just to let it know that we're dealing with a long value or a long int, effectively. Or so it allows that argument to be interpreted as a long int or an unsigned long int, which is specifically what a uint32t is. So, and then we're going to go qad rng and call our get value, and then uart stlink tx string cr, and we'll get it to spit that string out for us. So unless I've missed something, I believe we should be fairly good to go. Two errors. How have I misspelled it here? It's right in front of me. Okay, so this should be RNG update tick threshold in order to match the naming for everything else. So that should solve that particular error for us. Nice simple one, I like that. Always love getting spam messages in Twitch chat. Alright, so first things first, let's hook up our serial. We are connected. Let's just make sure that we have data correct. Wonderful, so that's all initializing correctly. So let's dump this code over onto our discovery device. And let's see if our random number generator wants to generate some numbers for us. So as we can see there, consistently giving us a bunch of random numbers that we can use to do various things with. So again, might seem like a very simple one, but it also makes for a nice short video. A perfect example of using a singleton class as well. So hopefully you found it interesting. And hopefully, you know, if you're making a game or something like my niece is, or doing something else that requires a random number, then you've got a bit more of an idea of how simple it can be to actually get the random number generator set up and actually doing things for you. Now, you can't specifically specify a certain number range. It's just going to give you a 32-bit number regardless that it spits out. But it's fairly easy to go through and actually add additions to the driver class that we've created to be able to limit or, you know, do a bit of maths on that 32-bit number in order to get something that you're going to find a little bit more usable for a particular situation, or even just trimming off a certain set of bits. So say if you wanted a number between 0 and 255, so an 8-bit value, you could always just take the lower 8 bits of the 32-bit value and use those instead. You can also, if you're after something that's a little bit more random, you can also do things like combining the values from the random number generator with values from an unconnected analog to digital converter pin and combine those together mathematically to get something that's even more random. If you're interested in that sort of approach, I'd recommend checking out our last STM32 basics video, which was specifically on analog to digital converters. So that might come in handy there. So anyway, hope you've enjoyed that one. If you've got any questions or comments, feel free to leave them. Chuck them on eBay. There is also our subreddit, which I'd love you to join, which is r/ones and zeros down there in the corner. Any questions or anything like that, you can always also send us an email on onesandzeros.contact@gmail.com. The code from this stream will be going up on GitHub fairly shortly so that you can have a bit of a play with it as well. Bear in mind, as far as the licensing of the code, it is free for private use. So if you want to use it on your own private projects, things like that, then feel free to do that, mess around with it, experiment with it. However, if you do wish to use it for commercial use, then you would need to send us an email on the Gmail address down there, and we can potentially discuss licensing options. Other than that, if you do want to help the channel grow further, we do also have a Patreon. Certainly love people to sort of help out there as well, because it's only going to help the channel grow. And lastly, I want to point out that we are nearly 2/3 of the way to our first 100 subscribers on YouTube, and there will be a giveaway happening when we get to 100 subscribers. So keep an eye out for that, because you could get to win yourself some cool little microcontroller toys and possibly some other bits and pieces as well. So hope you're having a wonderful evening or morning or day or night, whatever it is, wherever you are in the world, and thanks for watching.